2x squared minus 3x minus 5 is equal to 0. How do we solve this quadratic? We find the product of a times, which is of a and c, which is equal to negative 10. Now we're looking for two numbers when multiplied will give us negative 10, but when added will give us the coefficient of x, which is negative 3, and they are negative 5 and 2, gives us negative 10, and if we add negative 5 to 2, we have negative 3. So we'll rewrite this quadratic. It's 2x squared minus 5x and 2x minus 5 is equal to 0. Now minus 5x and 2x replaces minus 3x. And now we can go ahead and factorize this. We have x is common here. We have 2x minus 5 in the brackets. And we have 1 is common to 2x minus 5. So we have x add 1 is common to 2x minus 5. Now if x add 1 is equal to 0, that implies that x is equal to negative 1. And if 2x minus 5 is equal to 0, that implies that x is equal to 5 over 2, which is equal to 2.5. Now if you're wondering why I've just equated this to 0, if this is a number, because if we give the value, some value to x, in both cases, these are two numbers. And if this number multiplied by this number is equal to 0, this x add 1 could be 0, equal to 0, or 2x minus 5 could be equal to 0. And so we choose, we don't choose, but we actually consider both options because there's a quadratic, so we'll have two solutions or two values of x. They're not necessarily solutions in a practical sense. Maybe one would be a solution. In some cases, both can be solutions. Thanks for watching. I'm Alistair. Solve the quadratic equation. Well, we know the structure of a quadratic equation. Ax squared and bx and c is equal to 0. And this follows that structure indicated here. We find the product of a times c. A is 2 and c is 15, so that's 2 times 15 gives us 30. And we need two factors. When multiplied will give us 30, but when added will give us negative 30, the coefficient of x. And we have negative 10 times negative 3 will give us positive 30, and negative 10 added to negative 3 give us negative 13. So that's what we need. So we have to rewrite this. 2x squared minus 10x minus 3x add 15 is equal to 0. So the minus 10x and minus 3x replaces negative 13x. And now we can factorize these two terms and then separately these two terms to give us two pairs of brackets. We have 2x into x minus 5, and we have negative 3 common here to x minus 5, that's equal to 0. So we have 2x minus 3, x minus 5 equal to 0. Now if 2x minus 3 is equal to 0, that implies that x is equal to 3 over 2. And if x minus 5 is equal to 0, that implies that x is equal to 5. So these are the two solutions, x equal to 3 over 2 and x equal to 5 of this quadratic equation 2x squared minus 13x at 15 equal to 0. But don't take my word for it. Check these values of x. Both should evaluate this expression, and in fact this equation, to 0. Thanks for watching. I'm Alistair. Hello. Solve the quadratic equation 3x squared minus 12 is equal to 288. The first thing I'll do is, I'm curious to find out how I'll go about doing this, so I'll just rearrange it and make it a lot simpler. So I'll have negative 12 minus 288 is equal to 0. And then I can see right away, if I add negative 12 to negative 288, I get negative 300. And so now I have 3x squared minus 300 is equal to 0. And now I can rearrange again to have 3x squared is equal to 300. If I divide both sides by 3, because I can see that I can get a square number, I'll have x squared is now equal to 100. I know the square root of 100, which is x, and that's equal to plus or minus 10. Be careful, both values are valid solutions. In fact, just looking at the equation, because it's a quadratic, it has two solutions, and so don't forget to include both positive and negative in your solution. Here's another. We have 2x squared is equal to 72, and yes, this is a quadratic because we have a power of 2, or squared, x squared. We divide throughout by 2 and see what we get. So we have x squared here left, and now we have 36. We have a square number. Square root of 36 is plus or minus 6, so x has the values plus or minus 6 as the solution to this quadratic equation. Thanks for watching. I'm Alistair. Hi, welcome to Harris Maths. One useful thing about quadratics is being able to predict the number of solutions of a quadratic equation. We use something called a discriminant. And if you recall the quadratic formula, it's equal to minus b plus or minus square root of b squared minus 4ac, all divided by 2a. Now the discriminant is just this part here in the square root, under the square root sign, which is b squared minus 4ac. Now if this value, b squared minus 4ac, if it's greater than 0, or we can say if it's positive, so if it's greater than 0, meaning it's positive, then we'll have two solutions. If b squared minus 4ac is equal to 0, then we'll have one solution. And if b squared minus 4ac is less than 0, meaning it's negative, then no solutions. So before trying to factorize a quadratic equation, you could do a check on what's called a discriminant. and this will give you an idea of how many solutions, or if there are any solutions. Now bear in mind that we're talking about a quadratic, so it's in this form: ax squared add bx add c, which is equal to 0, and the constants a, b and c are the coefficients of x squared, b and the constant c respectively. I think that's it. Thanks for watching this video. My name is Alistair. If you have any questions or comments, please send them to me. Don't forget to follow or subscribe for more videos like this. Thanks and bye for now. Again, a similar problem, but we have a root now of 3 minus 4i. We'll call that alpha. That's equal to 3 minus 4i. And its complex conjugate we'll call beta, which is 3 add 4i. And we know the relationships alpha and beta is equal to minus b over a, which is equal to 3 minus 4i added to 3 add 4i. And this is equal to 6. Alpha beta, or we can write c over a is equal to alpha beta, and it's equal to 3 minus 4i times 3 add 4i. And let's give us 3 3s and 9, 12i minus 12i minus 16i squared, which evaluates to 25. So minus b over a is 6 and c over a is 25. Thanks for watching. I'm Alistair. Bye for now. Hi. Without finding a, b and c, determine minus b over a and c over a, given 2 add I is the root of ax squared add bx add c. So we have one of the roots, let's call that alpha, and it's equal to 2 add I. Now, the other root must be the complex conjugate of alpha, and we'll call that beta, and beta must be 2 minus I. This is proven and is always the structure of roots. One is the complex conjugate of the other. So we know that alpha add beta is equal to minus b over a. And we can write this as 2 add I added to 2 minus I. And this is equal to 4. And c over a is actually the product of the two roots, alpha times beta. It's c over a. And this is equivalent to 2 add I times 2 minus I. And this gives us 4 minus 2i add 2i minus I squared, which gives us 5. So we've already worked out minus b over a is equal to 4, and c over a, which is the product alpha beta, and c over a is equal to 5. So these two form the solution, the roots alpha and beta is combined in each one of these expressions. Minus b over a is alpha add beta, and c over a is alpha times beta. Thanks for watching. I'm Alistair. Hi there. So here we'll solve this. We have x is equal to minus 1 plus or minus square root b squared minus 4ac over 2a. And this implies that our roots alpha is equal to minus a half plus root 11 over 2i, and beta is equal to minus a half minus root 11 over 2i. Next, we have to confirm these two relationships, alpha add beta and alpha times beta. Right, now that we have our two roots, alpha and beta, I've written it here in the box. We have an alpha add beta. We'll just add these two. So we have minus a half add root 11 over 2i. That's added to minus a half minus root 11 over 2i. This gives us negative 1 because root 11 over 2i cancels with this minus root 11 over 2i. And all we have is minus half, add minus a half, it's minus 1. And this is equal to minus b over a. The quadratic, if just to remind you, it's x squared add x, add 3 equal to 0. So minus b over a, b is 1, a is 1, so minus 1 over 1 is minus 1. Next we have the relationship alpha times beta. That's equal to minus a half add root 11 over 2i. Multiply that by minus a half minus root 11 over 2i. This evaluates to minus, no, not minus, we have a quarter first, plus a quarter, add root 11 over 4i, minus root 11 over 4i, minus root 11 squared over 2 squared, which is 4i squared. Well, root 11 squared is 11. So what we have here is a quarter added to 11 over 4 is equal to 3. And 3 is equal to c over a. C is 3, a is 1. So that confirms both these relationships, alpha times beta and alpha add beta. Thanks for watching. I'm Alistair. This time the equation we have to solve is x squared add 9 is equal to 0. We know a is 1, b is 9, and c is 0. So we have our formula x, and we apply our values minus b, which is 9, minus 9, plus or minus square root of b squared, which is 81, minus 4ac, which is 0. So that's just root of 81 over 2. We know that alpha is equal to minus 2, 9 over 2, added to 9 over 2, which is 0, and beta is equal to minus 9 over 2 minus 9 over 2. So here we have minus 18 over 2, which is minus 9, and this is equal to 0. Now we need to confirm the relationships. Alpha add beta is 0 add 9, which is 9, and this is equal to minus 9, sorry, minus b over a. Minus b is minus 9 over 1, which is minus 9. The next relationship is alpha times beta. We know alpha is 0, beta is minus 9. This gives us 0. And this is equal to c over a. C is 0 and A is 1. And that confirms the two relationships, alpha add beta and alpha times beta, for the roots 0 and -9. Thanks for watching. I'm Alistair.